Boom! Alright, so we continue in our series where we're talking about the addition and the subtraction of fractions. In this video, we're going to go to the first level of the situation where the denominators are not the same. So in other words, let me call this level 2 in the grand scheme of things. Level 1 is the situation where the denominators are given as being the same. So you get a question, you get a situation where you have the same denominators. At levels 2 and 3, the denominators are not the same. You will have to do something to make them the same. So at level 2, what we will call level 2, is the situation where there is a clear relationship between the two denominators. And by clear relationship, I mean that one denominator is a multiple of the other one, which by default also implies that one denominator is a factor of the other one. So we bring in some vocabulary into the mix now. So in other words, there exists what we refer to as a, watch the word carefully now, multiplicative, right, relationship, R-E-L-A-T-I-O-N-S-H-I-P. There exists a multiplicative relationship between the two denominators. Now this is a principle that you could expand to 3 and 4 and 5 and any number of denominators, but we stick into 2 in this video, in this series of videos, because you have to master it for 2 first. You can't jump to 3 and 4 denominators if you don't know what to do with 2. Yeah? So a clear multiplicative relationship, some kind of big fancy vocabulary, right? Well, let me demonstrate it. Let us illustrate it. So let me go back to the 3 over 7 that we had started with in the last video. So let us say that you have to add 3 over 7, and it's saying 3 over 7 plus 9 over 14. Yeah? 7 and 14. It is clear from a visual inspection that these two are not the same. But if you have an awareness of your tables, it is also just as clear that there is a relationship between the 7 and the 14, because you know that 7 by 2 is 14. Yeah? Now this is where the whole issue of knowing your tables comes into the picture. Because if you don't know your tables, you had to spend time now trying to figure out if 7 could go into 14. That is time that you could use just running through the thing, because you see it and you know it, right? It is not going to usually be the case where you'll get something like, let me say 11 over 14 plus 23 over, is 84? 84. You wouldn't usually guess something like this. Right? You could, but you understand what I'm saying, right? Simple number, 7 by 2, you know, is 14. So in other words, back to our previous video, back to another video that I did before, where I was talking about the importance of tables. If you know you want the 12 tables, that is an excellent starting point. Of course, you want to expand beyond that as you go along. 14 by 6 is 84, by the way. All right? So, if you identify the multiplicative relationship between 7 and 14, in other words, 14 is a multiple of 7. 7 multiplied by 2 will give you 14. And then, by the same token, 7 is a factor of 14, which is to say, 14 divided by 2 is 7. So once you recognize the two denominators as being connected by multiplication, then you don't have a problem. Right? Because once you realize that 7 by 2 is 14, the next step is to convert this fraction into the equivalent value where the denominator here is the same as the denominator over here. So in other words, we're going back to the foundation principle that we discussed in the previous video to this one, where we said that the core, the foundation of any addition or subtraction of fractions is a common denominator. You must have a common denominator. And what you will find is that whatever method is used to add or subtract fractions, basically what they're actually doing is going through some process to make the denominators common. That is what it is. And you could check that as a matter of interest on your own. So this here is just a slightly different method, but it is a method that allows you to see the connection and make use of it and run through with it. So in other words, once you recognize that 7 by 2 is 14, well, all right. You now change the appearance of this fraction without changing the value of the fraction. So you're talking about the appearance, right? The appearance versus, let me say, the value. So the mathematical word would be the value. If we're talking about general stuff in life, we could talk about the appearance of something versus the substance of something. And that is a general principle that runs through life. Something might appear a certain way, it might look good. As we say here in TNT, it looking good from far, but it far from good. And I know they say that in other places too. Yeah? So the idea of being able to distinguish between the appearance and the value is something that he used here in maths, and it is an important life skill as well. We change the appearance of 3 over 7 by doing the same thing to the denominator and the numerator. So if we are going to multiply the denominator by 2 to change the 7 into 14, then we must also multiply the numerator by 2. So in other words, 3 over 7 is the same thing as 3 multiplied by 2 over 7 multiplied by 2. 3 by 2 is 6, 7 by 2 is 14. So having executed this process, we could now write this over as 6 over 14 plus 9 over 14. 6 and 9 is 15 over 14. Case closed. End of discussion. So in a case where the denominators are not the same, but you can determine that there is a clear relationship between the two. In this case, 7 by 2 is 14. Then you take this fraction and you multiply the numerator and denominator by 2 to change it from 3 over 7 to 6 over 14. And then you just write this over as 6 over 14 plus 9 over 14, which will give you 15 over 14 as the answer. So in other words, to reiterate the point that we just made, the appearance has changed, but the value remains the same. It's like when somebody put on weight, or when they lose weight, or when they wear new clothes, or when they take a new haircut, or when they change the hairstyle. The appearance of the person changes, but it's the same person. Right? And that is something that runs through a lot of life too. Sometimes the appearance of something might change. It may or may not be less aesthetically pleasing. Whatever it is. You might have a car, something happened, and the car not looking as new as it used to be. The car, you maybe drive to a muddy road, and the car looking dirty. The car might be dirty inside too, but it's the same car. Right? So the idea is that you change the appearance, but not the value. The form of the thing is different. It takes a different form, but the substance remains the same. right? And that is an idea that will run through some other things that we'll do in maths later, when we're talking about equations and all them kind of things. Yeah, all right? So the same thing could happen if we subtract it. So let me take the other fractions we had. What was the other fractions? We had 3 over 7 and we had 7 over 3. Right. So let us say that we have 7 over 3 and we're saying 7 over 3 minus 11 over 21. Okay, fine. Two denominators are clearly different. You could see that. That is basic observation. But again, you look at the two denominators and you realize that there is a clear relationship between the two, which is that 21 is a multiple of 3, and on the flip side, 3 is a factor of 21. You look at the 3 and you look at the 21, you go back to your tables and you know that 3 by 7 is 21. Or in other words, 21 divided by 7 is 3. So what you do, you take this fraction and you alter the form while maintaining the substance. You change the appearance, but the value remains the same. It's like when you have money. You could have a $100 bill in your hand, or you could have 100 singles. The appearance changes, but the value of the money you have in your hand is the same. Yeah. So what we do, we take the 7 over 3 and we say 7 over 3 is equal to 7 by 7 over 3 by 7. 7 by 7 is 49. 3 by 7 is 21. So now we can write this over as being equal to 7 over 3 is the same thing as 49 over 21 minus 11 over 21. And now we have a situation when the denominators are the same. 49 minus 11 is 38 over 21. And again, just as was the case up here, the appearance has changed, but the value remains the same. 49 over 21 is the same thing as 7 over 3. Form versus substance. One of the eternal themes of life. Form versus substance. Yeah. Alright, so this is the end of this video. Let me call it level 2 in the discussion of addition and subtraction of fractions. The next video coming after this, we will deal with the specific case of different denominators where there is no clear multiplicative relationship between the two. So stay tuned and check it out.